Yeah, so one day on Venus is about 243 Earth days, while 1 year on Venus is only about 225 Earth days, which is probably the least interesting point we can make in a conversation about a day on Venus. Hello, my name is Zeta. This is my physics degree. Let's talk about it. Now, the fact that Venus has a day longer than its year is a really excellent, gentle reminder that what is normal for us isn't necessarily normal for the entire universe. Right? It's a big place out there. There are going to be places that work in ways that grate against our logic, like the fact that a day can be longer than a year. That feels wrong to us because we've never experienced it, but universally speaking, it happens. It's also worth noting, though, that Venus doesn't just have a long day and that its day is longer than its year. It's like insanely long. Now, this is a graph from NASA Kids showing the length of a day on each planet. We see in the bottom right, we have Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. All of those planets don't even really fit on this scale. In fact, the only planet in there that has a longer day than Earth is Mars, and that's only 25 hours. We then see Mercury over on the side at about 1500 hours, which it's really long, but also Mercury is super close to the sun, close enough that relativity takes over, and it took us a really long time to even guess how long its day was. Venus is almost 6,000 hours. It doesn't even look like part of this data set. Like, that is what you put in the middle school homework where the kid has to circle the outlier. So your question immediately should be, why? And the answer is fascinating, and it actually helps us learn a lot about how solar systems form. So if you were to take a top-down look at the solar system, you would see everything moving in one direction. So all of the planets would be orbiting in one direction, they would all be rotating in that same direction, the asteroids and comets would also be following the same pattern. Everything's moving the exact same direction. But then there's Venus. So Venus is still moving the correct direction, but it's rotating the wrong way. Which, the fact that Venus is the only thing in our solar system that we can observe that does this just begs the question, why? And that gets into how solar systems form. So we all know that there are lots of pretty clouds of gas and dust out in space that we get pictures of all the time. They all look super cool. Those are where solar systems come from. Not all of them will become a star and then a solar system, but that's where they're born. So the best analogy we have for how solar systems and star systems in general form is tossing pizza dough. So you have a bunch of just giant clouds of gas and dust out in space, the same way you start with a ball of pizza dough, but as you start tossing it and rotating it, it's going to flatten out and it's going to stretch out. Just like pizza does, the gas cloud is going to do the same thing. It's going to compress and it's kind of going to stretch. And what's going to happen is in the middle, you're going to have most of the stuff come together and form a star or a couple few stars. And the rest of that matter is just going to keep spinning and orbiting around. And you're going to have tiny, tiny little things bumping into each other and becoming slightly bigger things as they stick together, like Play-Doh almost. Except eventually these things become asteroids and comets and planets and moons, and as this is happening, you go through a period of time where you have just a bunch of gigantic rocks bouncing into one another and colliding, and we're pretty sure that's what happened to Venus. So as it's working on forming, it's going around and it's rotating how it's supposed to, gets hit by another rock and starts rotating the other way while it continues on its journey. And we're pretty sure that's probably what happened. We're pretty sure that's why it is spinning backwards, and also why the day is so slow, because it had really little rotational energy after taking that impact. And that's one of the pieces of evidence that helps us solidify our idea of how solar systems form, and that is so weird and cool. And anyway, if you think space is neat and you are still here, you may want to give me a follow. I am obsessed with space, and learning how to communicate science in tangible ways is my passion. So if you have any questions, throw them in the comments, and I will probably get to them at some point.